Hi everyone, I'm going to talk about the determination of molar mass of aluminum in laboratory. How do we experimentally find the molar mass of aluminum? Alright, so what we do is basically we react some amount of aluminum with hydrochloric acid and we produce hydrogen gas. And we measure how many moles of hydrogen gas is produced in the reaction, and we convert that number of mole of hydrogen to number of mole of aluminum, and then we do some calculation and we find the molar mass of aluminum. Alrighty, so I'm going to show some experiment here. You see that? So this is the aluminum foil. Take a small piece of aluminum foil and put at the top of the balance here. So it is showing a number. The mass of the aluminum foil is 0.26 gram. You need to record this number exactly as shown by this balance. So record this 0.26 in your notebook. Otherwise, you cannot do calculation later. All right. So this 6 molar HCl is already given here. You need to put this 6 mHcl in a measuring cylinder, and it's about 15 milliliter. This number is approximate number. It can be 15.1, 15.2, a little less, a little more. It can be any number. You don't need this number later in calculation, but you need this number. So 0.26 is required number, or you may get 0.25 gram, 0.27 gram, 0.29 gram, whatever you get that number. You must record this number in your notebook. You really don't have to record this 15 ml. All right. So this is how we do the experiment. This is a round bottom flask here, and it is fitted with the cork and different pipe here. One pipe here and one pipe is going like this there, and this pipe is connected to the beaker here, and this pipe here is connected to this reaction vessel here. This is the reaction vessel. So what you do is you put aluminum foil here inside this test tube, and then you put this 15 ml of the hydrochloric acid here, and you immediately close this the top of this test tube with the help of the cork and the tube. You should not allow any gas to escape. So you should close as soon as you put HCl into it. You must immediately close the top of this test tube so that the hydrogen gas is not lost outside. So that hydrogen gas will come through this pipe and will be collected in this round bottom flask. All right, and this hydrogen gas will give the pressure, and due to that pressure the water get displaced. The water get displaced from here, and it goes like this and get collected to the beaker here. So the water is being displaced by the hydrogen gas and is being collected here. So you need to continue doing this experiment until all the aluminum foil is gone, or you need to see here uh, in the beaker, as long as the water is coming throughout through this pipe. Is when the water stops coming from this pipe here, the experiment is done. All right, so there are two ways to check whether the experiment is done or not done. One thing is that you need to look here if there is aluminum and it is giving the hydrogen bubble or not, or you need to look here if the water is still coming out to the pipe, or it is not coming. If it stopped coming, the experiment is done and you can stop the experiment. And you have to put a thermometer here, and then you remove this pipe and measure the volume of this water. Measure the volume of the water, how much water you collected here, how many milliliter of the water you collected here. You record that um, volume, and also put the thermometer here, and you have to record the temperature of that water. You see that? So the temperature of the water is 23 degrees centigrade here, and you have to convert this degree centigrade into Kelvin. So to convert degree centigrade into Kelvin, you have to add 273 to the degree centigrade number. So 273 plus 23 gives you 296 Kelvin. So this is the temperature you are going to use later in the equation PV equals to nRT. So how much water you get here in this beaker here? So the total volume of water displaced or water collected here or displaced by the hydrogen there. So the that much water is being accumulated in the beaker, meaning that much hydrogen uh, is being generated during the reaction. You see that? So when you convert this milliliter to liter, you have to divide by 1000, and 339 by 1000 gives you 0.339 liter. So that many liter of hydrogen is produced. So that many liter of water is displaced, meaning that many liter of hydrogen is being produced from 0.26 gram of aluminum. You see that? So that's how we explain this thing. All right. So this is a this one here is a pressure gauge. That this is showing the pressure, atmospheric pressure. So the atmospheric pressure shown by this pressure gauge is 750.5 millimeter of mercury. So this, you see that this red line here is calibrated as millimeter of mercury, and if you go here and see, that is 750.5, a little greater than 750.5. So that much is the atmospheric pressure today. So this is the atmospheric, this gauge shows the atmospheric pressure today. All right, so this is atmospheric pressure. And suppose you have a water here in this cup. Suppose you have some water in this cup here. This is water, and this water is being continuously being evaporated here at any temperature. So you see that. So this water also gives, this water vapor also gives some pressure to the surface of the water. So that we call as a is called the vapor pressure of the water. So people have already done this experiment, and they have tabulated temperature versus pressure, temperature versus vapor pressure of the water, and these are the tables here. You see that. So our temperature in previous slide I showed is 23 degrees centigrade. So at 23 degrees centigrade, how much water, how much pressure this water vapor gives to the pressure, to the surface, is that 21.1 torr. 21.1 torr is equals to 21.1 millimeter of mercury. So torr and millimeter of mercury is same. You see that. So this number, since we have 23 degrees centigrade of temperature of that water, so we look 23 degrees centigrade and we pick this number. If there was 26 degrees centigrade, you have to pick this number. Suppose there was 24 degrees centigrade, you have to pick this number, 22.4. But we have 23 degrees centigrade, so we pick 21.1 there. You see. So this is the vapor pressure of water at 23 degrees centigrade. Now, suppose we are doing the experiment with the help of this guy here. This is round bottom flask, and we have two things here. First of all, we have a lot of water here, and we also have some water vapor here. There are some water vapor. There is some water vapor. So this is also giving some pressure here, and we have some hydrogen we are collecting here. So this is also giving the pressure here. You see that. So we have two things here. One is hydrogen, and another is water vapor. So this water vapor and hydrogen is balancing the atmospheric pressure. So the pressure of hydrogen plus the pressure of water vapor is equal to the atmospheric pressure. All right. So atmospheric pressure is equals to the pressure of the water vapor there, meaning that this vapor pressure of the water and the hydrogen that is being accumulated here. You see. So this is the equation. So we call it as a Dalton's law of partial pressure. So put those number here. So how much is the P atmosphere? What is the atmospheric pressure? 750.5. So we put 750.5 here. What is the partial pressure of the water vapor there? The vapor pressure of water, that is 21.1 plus PS2. Now solve this equation and get PS2, that is partial pressure of the hydrogen, is equals to 750.5 minus 21.1, that is equals to 729.4 millimeter of mercury. So this is the millimeter of mercury unit, but we need the partial pressure of the hydrogen in atmospheric unit. So we have to divide by 760. 760 millimeter of mercury is 1 atmosphere. So 729.4 divided by 760 gives the atmospheric pressure. So that much millimeter of mercury pressure is equals to that much atmospheric pressure. So 0.959 atmosphere ATM pressure is given by the produced hydrogen gas in that reaction. All right. Now let's see here. So what is our equation? Our equation is PV equals to nRT. This is the ideal gas equation. You already get the pressure of the hydrogen gas. You already got the volume of the hydrogen gas. Now you know the value of this gas constant R, and you know the value of the the temperature in Kelvin. You already know everything. We have to calculate the number of mole of hydrogen gas here. You see, so the V we already found in previous slide. So this is 0.339 liter. The temperature was 296 Kelvin, and the pressure was 0.959 atmosphere of hydrogen. This pressure is of the hydrogen pressure, and the gas constant R is 0.082057 liter atmosphere per mole per Kelvin. So this is liter, this is liter here, this is atm, and this is atm, and this is Kelvin, and this is Kelvin. So all unit are matched here. So you can simply put the value of N is equals to you can just rearrange this equation. N equals to PV by RT. PV by RT, put this is the value of P, this is the value of V, this is the value of R, and this is the value of T. When you do the calculation in calculator, you get this number 0.0133. That many mole of hydrogen is being produced in that reaction. You see that? You complicate the reaction, and from that reaction you produce 0.0133 moles of hydrogen. All right, now you have to look the equation. This is the equation. So this is the theoretical the equation. The people have balance. So you see, aluminum reacting with hydrochloric acid gives aluminum chloride and hydrogen, and when you balance this reaction, you see 2 moles of aluminum is reacting with HCl to give 3 mole of hydrogen. You see that? Now we have to do some calculation here. Now I put here a small table here. You see, this is a small table here. So in this table I put this side is aluminum side. So aluminum, theoretically 2 mole of aluminum reacts to give 3 mole of hydrogen. You see that? But how many mole of hydrogen did we get? 0.0133. So this is 0.0133 mole of hydrogen we get. So how many mole of aluminum we took then? So we don't know what is Y mole here. So I just put a variable number Y mole. So I'm just assuming that I get a Y mole of aluminum. So Y mole of aluminum gave 0.0133 mole of hydrogen, or 0.0133 mole of hydrogen comes from Y mole of aluminum. So you just have to do some high school math here. So I just take the ratio. So Y by 2. So Y divided by 2 is equals to 0.0133 by 3. So I just take the ratio. So Y by 2 is equals to 0.0133 by 3. Now this 2 goes to the other side and gets multiplied there. So 2 multiply 0.0133 by 3 gives you 0.0088 moles. 0.088 moles, meaning that you were getting 0.26 gram of aluminum. And when I did the calculation and with the help of this hydrogen mole, I found that all the aluminum that I took was 0.0088 moles. All right, so that many moles of aluminum should be there in that reaction vessel while we are doing the reaction. Alrighty. Now this is the last slide of this presentation here. Now we have to calculate the molar mass. What's the definition of the molar mass? The molar mass of anything is equal to mass of that thing in gram divided by the number of moles of that thing. All right. So how many gram of aluminum you took at the beginning? You took 0.26 gram of aluminum. And when you did all the reaction and you calculate the number of moles of aluminum, you found that the number of aluminum was 0.0088. So you divide the gram mass by number of moles and you got 29.5. all right, so you found that molar mass of aluminum is 29.5 by your experiment. This is a experimental value. You did the experiment and you did the calculation and you found that molar mass of aluminum is 29.5. But this is not the theoretical or actual molar mass of the aluminum. The theoretical or actual molar mass of aluminum is 27. So during the experiment we do a lot of errors. We do error in measuring the mass. We do error during the water collection we do other kind of the error. There are many error that we can't avoid during the experiment, so we must have to calculate the uh, percentage error. All right, so what is your experimental value? The experimental value minus the theoretical value divided by the theoretical value gives you the percent error. So what is the experimental value? How much molar mass you got for the aluminum? You got 29.5. The molar mass of aluminum you found is 29.5 by experiment, but actual value is 27, and this is the actual value here. So this is a formula. You see that experimental minus theoretical divided by theoretical. So when you subtract this 29.5 minus 27 and divide by 27, you get 0.092, and if you multiply by 100, that it comes to be 9%. So during the experiment we get 9% error. This is pretty good actually. So if something is there within the 10% of the error, that is acceptable. So if you are doing this experiment for the first time and you got 10% error, you are very good. You did pretty good actually. Even in a very high level experiment, in the research level experiment, and after repeating many time, if I get 10% error, I am very happy. All right, thank you very much.